Hey, welcome back to your favorite trigonometry class. We're going to take a look at plane curves and parametric equations. Here's our objectives today, and we'll start out with a graph and a plane curve and go from there. First of all, the parametric equation uh, definition. Parametric equation and plane curves, if you take a look here, are where we're going to suppose that x's and y's are defined in terms of a third variable. We're going to use t, which is called our parameter, and they're defined on the same interval. So these equations would be our parametric equations that again are defined in terms of a third variable t, okay? And the graph of the points will become their ordered pairs when you input those t values, okay, which is called our plane curve. It's probably best to see this with an example here. So let's start out here. Here's our parametric equations. X is equal to 2t squared. We got y is equal to 3t. And where we have, for each t, notice t is defined between -2 and 2. Okay, so what we're going to do is we're going to set up a table listing some choices for the parameter t and then the corresponding x and y values, and then we're going to plot those points. Okay, so let's go ahead and set this up. So we're going to pick these t values again between -2 and 2. So let's go with integer values: -2, -1, 0, 1, and 2 to encompass that whole parameter there. And then notice that x of t is equal to 2t squared. And then we'll have y is equal to 3t. So we're going to plug our t values in. And then that'll spit out the ordered pair xy. Okay, so let's start out. So for example, if t is -2, and we have x of t equals 2t squared, so x of -2, 2 times -2 squared. So in other words, x equals 2 times 4, we got 8. 8. And then when t is -2, our y, for the y, our y of t is defined as 3t. So when we plug in -2 for the y, for that parametric equation, 3 times -2, we get -6. So the y ends up being -6. So this has given us the ordered pair 8, -6. Then we just keep doing that. So now we're going to do it for t being -1. We're going to plug it in. X of -1 equals 2 times t squared. So we got 2. And then y of -1 is 3t. So we got -3. So there's that x, y value. And then we just keep going with this. And now I'm going to plug in 0. So 2 times 0 squared, we get 0. 3 times 0 for t is 0. So this is the ordered pair 0, 0. Now let's plug 1 in. 2 times 1 squared is 2. 3 times the t value of 1. 3 times 1 is 3. 2, 3. And finally we plug in the 2. 2 times 2 squared, 8. 3 times 2, 6. 8, 6. And then let's go ahead and we're going to graph this. Erase some of this here. Have some room to graph it. Here's our x, y. So we got 8, -6 right here. Oops. Come on. 8, -6. There's that point. I got 2, -3. There's that point. I got 0, 0. Come on. 0, 0. I've got 2, 3. And I've got 8, 6. This thing always gives me trouble. 2, 3. And 8, 6 right up there. And then what we're going to do is we're going to plot these points. We're going to connect them with a smooth curve here. And notice the directions. I should put arrows in to indicate the orientation. We're starting with a t-value of -2, and it spit out this 8, -6 right here first. And then when I plugged in a t-value of -1, it spit out this 2, -3. Then when I plugged in t-value of 0, it spit out 0, 0, and so on. So it's going this direction. So the arrows indicate the orientation for this plane curve that we're graphing. Okay. Now I also did ask that that we find the rectangular equation for this, and so to do that, we want to write the equation the same as what we graphed, but without the variable t. Okay, and so since we have x equals 2t squared, and have y equals 3t, what I'm going to do is let me erase this again. Sorry, I need to get some room. Okay, so again, notice we have x equals 2t squared, and we also have this y equals 3t. So what I'm going to do is I'm going to pick one of them, and I'm going to solve for t. So number one, solve for t. I'm going to take y equals 3t, because that t looks real easy to solve for. I'm going to solve for that t right there. So t equals y over 3. And then by substitution, so I have x equals 2t squared by substitution. Alright, like I'm going to plug this in for that t right there. Come over here. So x equals 2t squared. I'm going to plug what t is equal to. Notice t equals y over 3. Squared. So we got y squared over 3 squared, which is 9. So x equals 2 9ths y squared. Okay. So if we made a table with this equation, we would get the same graph that is shown right there. In fact, let me pull that up for you on decimals. X equals 2 9ths y squared, just so you can see that. X equals 2 9ths y squared. In fact, I can even restrict the parameters, the y values. You know, when we had a t of -2 to a t value of 2, it went from -6 less than or equal to 6. It restricted our y values there. Let me put that down, kind of zoom out. You can kind of see, there it is. It just doesn't have the arrows on it indicating the direction. All right, but I did restrict that there for you. That's just kind of a nicer look at that. More explanation, sorry about that. Alright, here we go. Example 2. Alright, let's graph the following equations and find the rectangular equation again here for this one. Let me grab my pen here. Notice the t goes from 0 to 4. So let's go 0, 1, 2, 3, 4. That's our t input. And notice x of t is root t y of t is 1/2 t plus 1, and that'll spit out our x, y that we can then plot the points. Okay, so let's plug in 0 first. So if t is 0 and x is root t is my parametric equation, square root of 0 is obviously 0. And then y is 1/2 t plus 1, 1/2 times 0 for t, 1/2 0 times anything, 0 plus 1 of course is 1. So 0 comma 1 is our first point there. Now we're going to do it for 1. So I take the square root of 1, which is 1. And then I take 1/2 times 1 plus 1. So 1/2 plus 1, we got 3/2. So we get this ordered pair, 1 comma 3/2. And we're going to do it for 2. Square root of 2 is square root of 2, so that's about approximately 1.41. And then I'm going to plug in 1/2 times 2 is 1 plus 1 is 2. So I got 1.41 comma 2. Plug in 3, square root of 3 is 1.73. 1/2 times 3 is 3/2 plus 1. 3/2 plus 2/2 is 5/2. So I got 1.73 comma 5/2. Plug in 4. Square root of 4 is 2. 1/2 times 4 is 2. 2 plus 1 is 3. So I got the point 2 comma 3. Go ahead and erase some of this here. Have room to graph. And let's go ahead and graph this thing. So I got 0 comma 1 starting out right there. 1 comma 1.5. Oops, 1 comma 1.5. Sorry, right there. There. 1 comma 1.5. We got 1.41 comma 2. We got 1.73 comma 2.5. About right there. I got 2 comma 3 about right there. I didn't draw that too great, but it kind of goes like that. And that's the arrows again indicating the direction or the orientation, if you will. And it ending right there. Okay. Now, as far as the rectangular equation for the rectangular, the rectangular equation part of this, notice that we have x equals root t. So we could solve that for t by squaring both sides. So t would be x squared, right? So t is x squared. So that's number 1. Now by substitution, I can substitute that into y equals 1/2 t plus 1. So y equals 1/2 times t, right? Remember, t is x squared, so t is x squared plus 1. So we got 1/2 x squared plus 1. There's your rectangular equation, and you could restrict that from 0 to 3. And if you were to graph that, you'd see this same curve, 1/2 x squared plus 1 right there. That's our rectangular equation. Okay. All right. How about this next one here? X equals e to the t. Y equals e to the negative t. So notice our t's go from 0 to 2. So instead of going 0, 1, and 2, let me throw in, how about 0.5, 1, 1.5, and then 2. So we have a few more points, right? So x is e to the t, y is e to the negative t, in other words, 1 over e to the t, and then we've got the ordered pair x, y that's spit out. Well, e to the 0, right, if I plug in, if t is 0, and I'm plugging it into e to the t, so I've got e to the 0, anything to the 0 is 1, so we've got 1 right there. And then y is e to the negative t, in other words, 1 over e to the t. In other words, 1 over e to the 0, because t is 0. So we got 1 over e to the 0 is 1, so we got 1. 1 comma 1. That's our first point here, 1 comma 1. Now I'm going to throw in, I'll use my calculator. Now if t is a half, 0.5, I'm going to punch in e to the 0.5, e to the 1/2. And I get 1.65. And then I'm going to plug in y is e to the negative t, in other words. So now I got 1 over e to the 0.5. Now I'm going to plug that in. Calculator, and I get 0.61. So I've got 1.65 and 0.61. Now let's plug in 1, e to the 1, or e, 2.718, or 2.72. And then y would be e to the negative 1, so 0.37. Plugging in 1.5, e to the 1.5, I get 4.48. E to the negative 1.5, in other words, 1 over 1.5 is 0.22. And then e squared, the last one. E squared, which is 7.4 approximately. And 1 over e squared, so e to the negative 2.1353. So 7.4, 0.1353. 0.1353. Alright, let me get some room here to graph this thing. So we got 1, 1. Come on. There's 1, 1. I got 1.65.61. I got 2.72.37. 4.48.22. And 7.48.1353. It's going from here and it's ending right above that. I didn't draw that very well. It's a little lower than that, but right there, right? And here's my, again, don't forget your arrows on this thing. There's my orientation. Oh shoot, I forgot to put my, oh, I did put my arrows on that. Jeez. I forgot that. Alright, so make sure you got your orientation, you got your arrows going from that t value of 0 to t value of 2, right? So start to beginning there, plot those points. Now, as for the rectangular equation, notice we have x equals e to the t. This is a little bit tricky, actually, and notice y is e to the negative t, in other words, 1 over e to the t. So what I'm going to do here is I'm actually going to take 1 divided by each side. Okay, so 1 divided by x, make an equivalent statement here, is 1 over e to the t. So, and the reason I did this is a little bit tricky, but I want to do that because I get 1 over e to the t. What's it equal to? It's equal to 1 over x. So y equals 1 over x. Right? Another way you could do that is you could say, well, x is e to the t. If I take the natural log of both sides, then ln of e to the t is t. So t is the ln of x, right? And now I have, oops, now I have y equals e to the negative t And now I plug t in, ln of x, and e to the ln of x is x. Right? Either way, you get that y equals 1 over x for your rectangular equation there. Right? Either way that you do that. All right. Thanks for listening. I'm going to split this into a couple different parts, and we'll continue in just a second.